Well, thank you for the kind introduction. I maybe over-egged my background, so I don't know if it's that impressive. I work for Ecodomus. We're based out of San Francisco. I flew in from Los Angeles. I've been working in this space since about 2006, and was involved kind of early on pushing BIM. I was working for a technology and services company that provided services for AE firms and some general contractors, and then I made my way over to work for a facilities management technology and services company in 2009. And when I made my move, I was thinking that there was going to be a real opportunity to leverage all the work and innovation that was going on the AEC side, and to get owners, really excited about this great stuff and how it's going to be this new tool that would improve how they operate their building and so on. And they weren't interested, and this was 2009. So only recently have I seen a kind of shift in interest where owners are really kind of being proactive in terms of how they can take advantage of all these innovations in the industry that's primarily been driven by the AEC supply chain. Just to kind of frame this discussion, you guys are probably all familiar with, obviously, with NBIMs. It was mentioned earlier by Alan. And actually, just to touch on what Alan said, even speaking as American, I do really agree with what he described as your opportunity here in Canada to really kind of be at the forefront of innovation in this area, because you guys have it's not my phone, I swear. My phone's in the bag down there. Because you do work on large-scale projects, you have some unique delivery methods in terms of your infrastructure with the P3 and obviously a lot of design-build projects. And because you're big, but you're not so big that you have the same. Let me just say that U.S. public agencies don't work so well together, and I think that maybe we have an opportunity because of the scale to really collaborate a little bit more effectively and efficiently than we have in the U.S. But just to kind of start this off, to frame it, the idea of BIM is as it's commonly practiced, I think a lot of times we think about it obviously as a software, or the process of modeling, or a model itself. The NBIM's definition, I think, is telling. I want to start with it because it kind of hits on two of my key themes here. One is, can you guys hear me okay? One is the concept of BIM is a digital representation of the facility. So essentially, the facility, the building we're standing in, let's say there's a digital version of it. And the second part is the idea of being a shared knowledge resource for information. So if you can start thinking about how you can ally the geometry and the metadata, it actually adds value to both. Because as you know, if you look at a BIM object and there's attributes associated with it, it adds value to what you're looking at, and so vice versa, right? So about us, we are a technology and services company. We have a platform that a lot of owners are using to take BIM and integrate it with the different systems they use to manage and operate their facilities. We have a number of international partners, not in Canada, although we'd like to start working with people up here. And what we found is the GSA did a number of BIM for FM pilots. Most of them, they were using our platform as the integration tool for it. USC was one of the pioneers for BIM for FM. The FAA, NASA, they've been doing pilots. But what we found is that the first step, almost always, is as an organization stepping back and figuring out your plan for what you want to do, the business cases for doing it. Because if a lot of times our focus is on, when we talk about use of BIM and FM, we talk a lot about technology integration as opposed to what's far more important, which is the process integration. So what is the business case? What are we trying to accomplish here? What workflows can we automate? What processes can we improve and make more efficient? So most of our engagements have typically started with consulting, sitting down and determining what the objectives are that a client has and what they're hoping to achieve, and the technology comes later. I'm going to have some water. My mouth's a little dry. I don't know if you guys saw the State of the Union, but afterwards the Republican rejoinder, the guy had to take a sip too after. All right, so again, there you go. There's the NIST study that Tony introduced. You guys have probably seen it before. Unfortunately, there's not a lot of new stuff for me to throw up there, so I have to keep using it. But there's a couple kind of key areas here. So we obviously know that there's a lot of waste, and whether or not it's being measured or not, I think anecdotally we all have ideas of where it exists because we've encountered it everywhere, right? And a couple key points. One is the construction industry, or the industry we work in, has not made strides in productivity like every other industry, right? There's still significant inefficiencies because of really bad data management. And that extends all the way down the line in terms of the AEC supply chain to the people who actually operate and manage their facilities. So something needs to be done. And so the key is figuring out, okay, well, what are the different methods that we can use for improving how information gets exchanged between all these stakeholders? Because if information is exchanged more effectively, they make better decisions, and obviously, ultimately, you have less waste and buildings perform better. So I kind of wanted to tie this to another wider trend, which is the concept of big data. And most of you, it gets used a lot. Most of you are probably familiar with it. But the general concept is we have this ever-expanding digital galaxy of data, right? Every time someone posts something on Facebook or buys something on Amazon, whatever. So this vast digital galaxy of data. And we're starting to get our heads around how people can review that data and look at that data in context so it becomes usable information. And it's primarily big commercial organizations, scientists, people like that. But it has relevance to what we're dealing with, I think, in the building industry. If you think about, if you guys look at if you look at smart buildings, for instance, and there's tons of data points or sensors that are set up in these buildings, and they're tracking all these data points, right? And you have, if you guys have thumbed through submittals, and you look at all the information in submittals and O&M manuals, or you open up a Revit file, look through metadata. So there is some real challenges with we've got all this unstructured data that exists in lots of different silos, and we're figuring out how to get a handle on it. The opportunities it brings, of course, is that you have the digitization, and not scanned documents, although that does help with cleaning up the plan rooms, but digitization in terms of allowing computers to automate the process of sifting through data, finding it for you, right? So you can create improved access for the different stakeholders who need to get to that information. And that opens up the opportunity for advanced mining and analytics across lots of different systems. So if you think about an airport or a university that has tons of buildings spread out all over campus, and they may have 10 different types of air handlers across that campus. So what if they can start analyzing and looking at information that's being tracked in BAS, or information related to whether or not preventive maintenance has been performed, what the design specs have been, and to correlate that with GIS, weather-related data, so they can start actually doing a real comparison on how assets perform against one another. So spoiler, BIM doesn't solve it. That's a silver bullet, by the way. And the reason why is because I think we know this, when you look at this whole ecosystem of stakeholders that are involved throughout the facility life cycle, they serve different masters. They have different priorities and responsibilities. And I think the slide that Tony showed about the importance of an operator in terms of data, I think you can see the distinction between the types of tools they use as well, in terms of data management tools that an operator will use for managing maintenance, for instance. They rarely have any graphical interface. Building automation systems usually have some sort of limited visualization interface that they can access. But really what you have is these different systems that have existed for a while, many, many years, and they've been operating in exile from one another for so long that they built workflows and customer bases that are very, very specific, and they don't engender themselves well to actually sharing information with one another. And then the other thing too is budgets. I think one of the overwhelming challenges that I know that we face is encouraging people to make investments with their capital projects to drive efficiencies down the line from an operational standpoint. In the U.S., a lot of our school funding is K through 12 comes from bond money, so the public, taxpayers funding it, and so there's often a lot of money available for, rehabbing facilities or delivering new buildings, but never any operational budget to operate them efficiently. And so what we've been trying to push is the concept that if you can leverage your capital project budget efficiently, you can drive efficiencies down the line. But rarely, if you talk to a capital projects PM, he's not willing to spend $1 to save $2 for the guy in the other building who has to manage and operate the facility. So that's one of the big challenges we face. And then maybe organizationally, when you think about how budgets are appropriated or how you guys make investments, there may be some ways of addressing that up front. But when we do talk about information management, kind of going back to what I mentioned earlier, the alliance of BIM, or the geometry and data, which is to think of BIM as a foundation for how information can be exchanged or managed or captured. And three kind of, it's a little bit vague, but I'll explain it. I mean holistic in the sense that it can encompass everything, right? So it can be very, very broad, depending on what you want to capture. It can be something as simple as, or as narrow as MEP coordination, right? Or it can be something as broad as incorporating scheduling, for instance, if you're talking about the specific project workflows. It's organic in the sense that you have lots of different stakeholders who are contributing to it. It's not one person that's responsible for the BIM. There's a whole community of stakeholders who can either use it for reviewing information or adding information or generating information. And then it's atomic in the sense that you can start getting as granular as you want to get. And that would be determined by the purpose, whatever your purpose is, your business objective. So a more advanced facility might want to have a more specific information related to operating their mechanical equipment, whereas a school or an office building might not be as interested, right? So again, when you're thinking about information management, you can think of the BIM as being, it can expand or contract depending on what you want to use it for. So outside of the theory, whenever we sit down with an organization, we always talk about planning for it. The first step is always to begin with the end in mind, which that might be overused too, but it's important because you got to start with the strategy, and the owner needs to figure out what are their overall objectives for their projects and for their facilities. And this should start at a really high level. They should talk about whether or not they want to drive down costs related to operations and maintenance, if they have goals related to greening their buildings and so on. And then you can start getting tactical and more specific about how information can enable enable them to achieve those goals. And it should always start with understanding where the deficiencies are. So they need to have a look at their processes and identify, okay, well, where do we have issues? Where do we have waste? A lot of times, some of the feedback from that can come from their suppliers and their consultants, right, who've been through the process of dealing with their guidelines and recognizing that their project managers don't know what they're asking for, haven't been trained properly to get them what they want. And then you have to come up with a vision state, so an idea of where you want to be. And that can be something as simple as saying, well, we want to have BIM guidelines. We want to have or it can be more advanced. You can say, well, you can detail a system architecture map to show how information workflows can take place between different stakeholders. But the goal is to have an idea, at least at a more tactical level, where you want to be, and have specific work tracks that can lead you to that goal. And then around the strategy for implementation, we're huge fans of pilots. And I wasn't familiar with the SSM model, but intuitively it makes sense, because I think for those of you who've been maybe made a foray into this space, you understand that you really only figure out sometimes you don't figure out stuff out until you actually start doing it. And a lot of times you uncover lots of waste or areas for improvement after you've started doing something, after you've tried to make a change. And so it's a very iterative process, and therefore we encourage identifying pilots and specifying some outcomes, some goals for the pilots. Oh yeah, and measurement. Again, part of measurement is just figuring out whether or not you're achieving some of your objectives, met your vision statement. Only part of it is financial, though, because if some of you have started tackling this, you may find that it's really hard to identify hard cost savings with BIM. I mean, you can, don't get me wrong, certainly from within the AEC processes, you can point to savings pertaining to design documentation time or the avoidance of significant change order and so on. So I mean, there are ways of doing it, but in reality, from an operational standpoint, a lot of what it's talking about is soft costs. If you have $1 million that you spend on your operational budget and you're able to improve efficiencies by 25% to make your guys 25% more efficient, you're not going to save 25% of that $1 million because they're still employed by you. But you will be able to get them to start doing more proactive preventive maintenance. And so the balance of preventive maintenance versus on-demand maintenance might become in more equilibrium. As it is now, most organizations, almost everything they do is on demand. They get called because something won't work, right? Because they're not performing their scheduled maintenance. So anyway, so there's different kinds of metrics that you need to look at when you start trying to figure out how am I going to validate investment in a lifecycle BIM approach. And so we always say, pick a whole bunch of use cases. based on the deficiencies you found, pick a whole bunch of use cases, and try and figure out how you can measure success against those particular use cases. Simple place to start, obviously, from an owner standpoint, is figuring out what you want information on. One of the first things we almost always do in a lot of projects we've been involved in, which have been during project delivery when they're aggregating information, performing QC on the information, is to always start with a list of the critical or major types of equipment that an owner wants information on. It could be related to spaces or systems and stuff of that nature too. But it's a really simple process you can go through, and typically most owners have an asset man, they have an ERP system, they have a CMMS system, there's a list of stuff they're tracking. And they might not track valves or fire dampers in their CMMS, but that still might be information they want to have, right? So they got to identify that and make it very clear for the AEC consultants that's what they need information on. And then they need to figure out what you want to call it and how to classify it. And I know that a lot of people here are probably designers who probably have standards and families that they use, and maybe some of their own nomenclature approaches for what they call things. But speaking from an owner's perspective, when you're designing something, you should be calling it what the owner wants to call it. I was in a meeting with one of the first meetings with Kaiser Permanente. We actually helped. Kaiser Permanente is a big managed health services company in the U.S. Sort of like the only vertically integrated one. And their CIO of their National Facility Services Group, one of the first things he said when we started talking about BIM was he wanted to make clear that an asset is an asset is an asset, which means that it doesn't matter if the designer's touching or the builder's touching or the operator's touching it. They need to know what it is, and there's no reason why it should have different names or that it should be not identifiable between different people. Because ultimately what you want to do, with the kind of state where you want to be, is that when information gets created, it gets captured and kept until it gets transitioned to closeout into the system that actually operates that particular asset or manages that particular asset, right? So VAB shouldn't be called VAB John because John designed it. It should be called whatever the owner's nomenclature requirements are for it, or at the very least so it's identifiable. So that should be established up front. USC has a really kind of simple, elegant way that we typically recommend whenever people are asking us about nomenclature, which is utilizing the Omniclass naming convention, the National CAD standard abbreviation, and then for the type, it would be the operation description. So it could be, I don't know, the air handling unit is AHU, operation description could be rooftop, so it would be like AHU rooftop. But then the individual component or asset would be AHU and the tag, so AHU D1 or something. So anyway, so it's a really simple way that makes it very easy for their project teams to understand what they need to call things. The second part is classification. I expect most of you are probably familiar with master format and unit format, hopefully Omniclass as well. This is important too for an owner's perspective because it makes it a lot easier to mine or analyze data in big batches, right? Because you can quickly classify certain types of data. So if you have, for instance, I know that unit format can plug into RS means or it's used for facility conditions indexing. Omniclass can sort of sit above both master format and unit format. But if you're an owner and say you've got 10 buildings and they've all been delivered and your equipment or your assets have been classified correctly, you can quickly do a search against classified assets. So you don't have to look up AHU or VAB. It's been classified, and that's a good way for mining data. And the second part of normalization is to structure the data, and this is primarily for, and this is I'm referring to the capture of data. Looking at projects. Do you guys know, how many people here are familiar with COBE? Okay, so a fair few. I'll try and divide the line between not talking too much about it and explaining enough of it. So COBE is basically just an open standard data specification format that a gentleman from the U.S. Army Corps of Engineers developed. And the idea was to create a common schema for how data can be collected or how it can be structured, which means that the software vendors can export or import it, and then the AEC supply chain can figure out how to work with it. But the idea is to structure data so that you are Paisley. Don't forget. I don't know how to turn that off. Sorry, guys. Okay, so it's The reason why it's important is because what it's talking about is life cycle data. So it's not information that the designer or builder is really interested in for design purposes, construction purposes, but it is stuff which you typically provide as part of your O&Ms. All right, so so the concept of COBE again is there's kind of two ways of thinking about it. One is if any of you've seen a COBE deliverable, it's like I think of it as a product and a process. And the product is this think of an Excel spreadsheet with a lot of common tabs where you have different categories, and each category has default fields. And if you just think about that big spreadsheet, picture in your mind. And one of the work tabs is facility, another one is floor, one is space, one is zone, one is component, which is essentially the individual asset or instance, one is type, and one is system. And what happens is they're all, it's an interrelated database, but if you provide a data set, which is in the COBE format, most of the major CMMS packages have a script to consume the data. So rather than back up a truck full of binders or give them a disk with a CD with a bunch of O&M manuals on it, you give them an Excel spreadsheet. Touched on what Tony spoke about earlier, which is the digitization is valuable because computers know what it is, right? If the computer knows what it is, it means you can write a script to automate how information is transferred. So part of it is that deliverable format. The second part is the process of it. So the process of COBE kind of ties in a lot of lean principles, which is you collect the information as soon as it becomes available. So you don't wait till the project's done and then go around and ship off a bunch of O&M manuals. When the VAVs have been installed and approved, the mechanical guy responsible for installing the VAVs will go in and provide information on the serial numbers, the make, model, manufacturers, and so on. So the idea is you capture the information as it gets created throughout the course of the project. So when you get to the end of the project, you have this clean, nice data set that the owner can take and push into their CMMS package. And the way it's structured is if you think you have a facility that's made up of floors, and then there's spaces that are part of the floor. So let's say you have room 101 as a space, but then room 101 might exist in multiple zones. So let's say you've got an HVAC-related zone, an occupancy-related zone, or so on. But then the individual, say VAV, is the component is located in a room. So VAV 101 is located in room 101, and you need to know the serial number, when that particular one was installed, and so on. But that VAV is also part of the type. Those of you familiar with families and instances, I might be speaking too much about it, but whatever, you guys are a captive audience. Can't go anywhere. But a type would be like if the VAV is a 6-inch type. So let's say you've got 100 VAVs in the building, but only 5 types. So from a data collection standpoint, for all the VAV 6 inches, you're collecting the make, model, manufacturer, O&Ms pertaining to 6-inch VAVs, potentially all. So from a data collection standpoint, it makes it easier to collect information because you're only collecting a few unique fields for the individual component. You don't have to collect make, model, and manufacturer 100 times. Yes, sorry. However, when we talk about COBE, there was a long list of owners who've been asking for COBE for a while. It actually rarely gets delivered, or up until now, it's been rarely being delivered because it's poorly defined contractually. And also the tools that you guys use on projects, the idea was that the tools or the software vendors would build better tools for managing this data deliverable process. And they have made some strides in it, but they're not quite there. So for instance, if you're using Revit, Revit has a COBE toolkit, which means it will collect, you can insert the standard parameters for COBE information pertaining to type and component and space. And you can export directly from Revit a COBE spreadsheet, right? However, whoever's generating the Revit model, they're most likely it's not going to be the mechanical trade or electrical trade or the plumbing trade or even the general contractor necessarily, depending on what they're doing. So if you want to work in a lean, collaborative environment, Revit's not a data management tool. You should be collecting information in Revit based on, as you're designing, you should be obviously correctly inputting information in Revit, so populate schedules and all that, but you should not be inputting information related to installation date, because the designer, the person responsible for the authoring the BIM, they're not responsible for the installation. That's the trade, right? So he needs to be responsible for that. So the tools aren't quite right. And even if you look at there's some field verification software that can collect some COBE data as well, although there's some challenges with that. And then Excel, if Excel is not really a collaboration tool either. And so when people have been doing COBE on projects, what they always do is you'll have a general contractor who knows Revit. He'll stuff a bunch of information to a Revit file and export a small COBE set. Or you'll have people trying to data enter into an Excel spreadsheet, usually one person just surveying O&M manuals, instead of having a collaborative environment where everyone who's responsible for the information they're responsible for are providing it to a single database in the same way that every other organization manages data, right? Except for our industry. So the tools are kind of deficient. I obviously have some recommendations on a tool you could use to help with that, but I'm biased. But the tools are getting better. But an owner should always define the means and methods, and one of the important parts is what tools they're going to use. Another one is related to who's responsible for what. And this goes back into the collaborative process and defining up front roles and responsibilities. And I think a lot of times when you hear pushback about doing BIM, a lot of times it's because there's not clear guidelines and standards or information about means and methods that the consultants push back, not because they don't want to do it, but because if they say yes, it could morph into something far more than they expected. Or if they're already if they already have won the contract, they are less inclined to do it because they can't get their trades or their consultants to get on board without charging them a lot more money. So you got to define it up front. Milestones is important because you don't want to just have everything at the end. You can, but the best way to do it is as you go, because you can check on progress. And then lastly, you need to determine the workflows. So information exchange. So I'm going to show 3 different examples of how BIM is being used for information exchange. There's some more that I can share offline. I had some videos actually for these. I didn't insert into the PowerPoint, although maybe it made the presentation more exciting. But I can always share those later if you need a more visual understanding of what's going on. But the first is the University of Southern California. So USC is one of the biggest private universities in the United States. They've got about, I think, over 13 million square feet. Big university, very wealthy too, a lot of rich donors. And they, in 2009, started looking at how they could use BIM and insert into their facilities management processes and as one of the tools they use. So they built guidelines around their requirements from their AEC teams, from their that the capital construction guys would need to enforce, related to information and that they needed at closeout for managing for managing their facilities. And they were requiring the AEC teams to actually provide a Revit model of all the disciplines with a certain amount of metadata that they wanted to have in their model. And the reason why they specified Revit was because they wanted to have a single authoring tool for all the disciplines. And so through the process, as the general contractor and trades, as they're going through, they would be sharing the information about what was installed with the designer, and the designer was retained to update the original design model to reflect what was built. Again, not to be a specific proponent for a specific software. Sorry, what was that? 10 minutes? Okay, thanks. But it created so it creates a collaborative environment which the designer is still involved until the end. And then when the project's done, they're going to take the model and they're going to integrate it directly with their CAFM CMMS tool, which is famous, as well as with Honeywell EBI, which is their building automation system. Oh, and they have a large engineering school, so they've put some of their students to work modeling their existing conditions in Revit. And they haven't been modeling the MEP equipment, they've just been doing the architecture structure, and their students work cheap, and they have a laser scanner, so they're building a database of Revit files, which they eventually plan to integrate into their whole facilities management system, but they're not there yet. So the primary objective is to get something that when the project's done that will fit with how they want to use it for facilities management purposes, so they don't have to repurpose it. So to build their guidelines so that what they get at closeout they can start using. The second part, and this is I think actually very, very underrated, but speaks to the data fidelity issue that Tony highlighted, which is rarely do owners get all the information. They rarely get a complete data set anyway. Nor would they ever know if they got a complete data set, nor would you know as a supplier whether or not you ever gave them a complete data set, right? You just cannot QC it. So they wanted to automate the process of making it simpler to understand whether or not they got everything, and from an AEC standpoint, if those guys knew they had provided everything yet. And then ultimately, by having all that information, being able to integrate it, they can optimize their facilities and improve how their facility managers did their work. So the first start was the guidelines. I can't stress this enough. Guidelines, they need to be clear and enforceable. And that means that if you guys are familiar with some of the BIM guidelines that have been floating around for years, a lot of times they're very great, expansive documents, but they cannot be managed, or they cannot be understood or comprehended. Which means from a consultant standpoint, you have no idea how to bid it. You also, from a project management standpoint, as an owner, you aren't really managing to it because you haven't been provided with the adequate resources or training to understand how to manage what your deliverables are. But if you can make it very clear and tie it not just to the processes that the AE or the GC are using, but to make it specifically related to outcomes that the owner needs, because you guys, the AEC team, should be innovating in terms of improving your own discrete workflows around coordination and design visualization and so on. But be very clear about what you require from the teams. The other part is obviously the Revit file closeout, and then they have a template for the BIM execution plan and the COBE execution plan that they hand to the AEC teams, who use as the foundation for developing their execution plan. So it's not so for instance, they've got 10 projects going on right now. They don't have a different BIM execution plan from every single GC that looks like that GC's BIM execution plans. They're standardized enough that it's clear and it makes it easier to manage and enforce. So the information, what they're doing throughout the process is the models are taken and they're extracted up to the web, where the data is managed, the lifecycle data is managed in a web-based environment that has a web forms interface and a model interface. And the model interface can be used for data collection, but a lot of the data collection just happens in basic web forms, where a trade will log on, see his name next to equipment, and type in the information he needs to enter there as soon as it's been approved. And because this is being managed in the cloud in a normalized SQL environment, it means that you can start running QC reports so they can check throughout the process, where are they at in terms of what they asked for, have they gotten it all? Which makes it easier not just for the owner, but it makes it easier for the AEC teams because they can use it as a progress check. They can see, okay, Mr. Mechanical Trade, you still owe me that information. And he can check his progress that way, or she. In the closeout, they take the model and integrates, pushes all the information into Famous, but it retains a link back to the model. So we're not even breaking the link in the way that you would with the COBE file, which is the one downside to a COBE file, that you're breaking the link from the model, because you're just basically giving them an XML data export, right? So from a lifecycle change management standpoint, you've lost correlation with the model. But with the way they're doing this, there's a direct link to the model so they can manage that change. And then they're integrating it with BAS. So just touch on make sure the guidelines are clear and enforceable, make sure your means and methods are clear too. Focus on looking at how you can save money operationally by taking advantage of the capital budgets available for things. And then this one kind of ties to the next part, which is the conversion of existing facilities to BIM for use for FM purposes is a very different plan than than actually taking new facilities. So what the FAA did was they have this massive modernization program going on called NextGen, and so they've done a proof of concept on an existing facility where they went out and they created a BIM of this existing air traffic control tower and some office buildings. And so the goal was to create what they call a facility information model that can improve efficiencies related to how they operate and maintain their facilities. So the goals they kind of set were, okay, well, we want to use BIM because it's a better representation of existing conditions in CAD. And it also will make sure that we have better information than we had in the traditional way. They wanted to streamline O&M processes and also create a better strategic insight so you can start looking at things at a high level in terms of how things are performing and make better proactive decisions. And then they also have issues related to emergency planning recovery services. So one of their use cases was around that. So the model was created from the 2D drawings in Revit, and we used laser scanning to augment the model, because what was in the CAD files wasn't exactly what was as built, or the existing conditions. So then we used that to update the model. And then geometry was collected. Only some of the geometry was collected in the Revit file. The geometry collected in the Revit file was like naming, making sure things were named and classified correctly. And then the rest of the data was either collected from the legacy data systems, the CMMS and CAFM, or in the field using our tool, the mobile device, a handheld tablet device. And then the integration was performed between, that was linking assets in the middleware with TMA systems, which is a CMMS package, with spatial information that was being tracked in Archibus, and then Schneider Electric, which was the building control system they had. And then they put all the models on an Esri GIS interface, an Esri ArcGIS interface, so that they could look at BIM data in context to layers that are managed in Esri, which can be utility related, it can be weather related, it can be natural disaster related, and so on. So the idea is that because they have facility managers who manage facilities spread out over a large geographical area, being able to do analysis from wherever you happen to be on a problem call can save tons of time and fuel costs, because people don't have to drive to lots of different locations to figure out what it is they need to do and then drive back to get whatever they need to get. And GIS is a big deal for airports, and I'm sure Tony can speak to that, as can the lady from Calgary Airport. It also improved some of their disaster planning, at least from a proof of concept and their disaster planning strategies. It was also, by using BIM, it improved the inventory process for figuring out what information they had, because all of a sudden they had much better visual representation of the data. So improved that inventory process. And based on the business cases they did, they were estimating they could save 60% of their O&M service time in resolving issues pertaining to maintenance and facilities management. And then the last one it's sort of a hybrid of what the other ones were doing, but as a slightly different, a little bit nuanced to it. And this is taking it to another level, which is not quite as well defined as just improving efficiencies and strategic planning. This is related to comparing simulated predicted performance against actual performance. So there was a large federal building in Camden in the U.S. that was, I think it was over 100,000 square feet. And it was a renovation based on, and it has expectations of performance based on how they renovated it, right? So the engineer said, this is going to perform to this level. So what they did was they were going to take the model, use BIM to support some of their energy simulation and create some baselines and benchmarks, and to compare it against actual performance over the course of a year. And the value is, of course, for those of you who've been involved in energy modeling, a lot of times energy modeling is I wouldn't say it's a dark art, but there is a lot of times subjective interpretation that goes on when you're looking at the information. You obviously don't always have all the information in hand that you need to do simulation. So part of it is related to improving simulation. Part of it is also it's related to improving analysis. Because a lot of times when owners are looking at how a building performs, they're looking backwards at utility bills or utility usage, right? Which doesn't tell the full story of how a building is operating, or indeed even if it's operating optimally. So they wanted to implement this, what they call monitoring-based commissioning tool, which could analyze performance at a high level and a low level. And then to create a sort of a feedback loop where they could justify spending money or investing money in greener buildings because they're able to demonstrate improved performance. And if it's not improved performance, it's understanding why. Being able to actually analyze, well, the building's not performing, why? And having to call the engineer and say, why is the building performing like you said it would? And he said, well, talk to your facility guys, they don't know what they're doing. So anyway, so it creates a more transparent environment for measuring and monitoring performance. So we've integrated with Energy Plus, which is the Department of Energy's energy simulation tool. It uses, you can use IFC files, and you can input parameters related to, well, whatever parameters they would input to establish some of the baselines for their expected performance over the course of the year related to loads and occupancy and so on. And then the comparison against the BAS data points will give them a direct correlation between what was predicted and what actually happened. And they're going to monitor it over the course of a year and see what happens. So again, I wish I could say we're going to give them some sort of ROI, but there's no ROI on this to give them. All we're hoping to do is to give them a better way of understanding whether or not the building is performing like it's supposed to. And if it happens to not be, maybe this enables them to actually analyze and diagnose why it's not, right? So a lot of this involves taking a leap. And in this project, we were awarded the contract 6 or 7 months ago, but the model wasn't ready because it hadn't been prepared. It had been prepared to support AECOM's design requirements. It hadn't been prepared to support energy modeling requirements, so it had to be reconfigured and repurposed to support energy modeling. And it wasn't as built, so we had to go back and we had to review what was actually built, look at the Navisworks files, do some comparison in Celebri, and actually reconstruct the model so that it reflected what was built. And then the BAS, we didn't have access to the BAS, and there's all sorts of issues tunneling to get the data points. So we just started tracking data points, and we hope to have some interesting news and case studies, or this could be a more expansive case study we can share with you later. So some of my closing thoughts: the information, right? It's the data and geometry together in concert. You want information, you want data that makes sense. I think that the AEC teams have an important role to play in helping owners along. I think it's really, really important. You guys really, I think it's important that you use some hand-holding. But ultimately, the owner needs to find their requirements. Their requirements should not be dictated by the designer or the builder. An owner should remember that. They should be focused on outcomes and their overall objectives. And the incentive systems are, as we know, sometimes run counter to one another. So you need to find ways of looking at improving how stakeholder incentives are aligned to meet your overall objectives. Proof of concepts, measure it, and do something. If you're an owner, do anything. Start a pilot, do something, because otherwise it's going to pass you by. That's it.
I'm Simon Gibson from Cancel. We supply Autodesk software to the AEC industry throughout Canada, and I'd just like to ask you if you feel software like Autodesk Seek or something similar that has, as a library of 3D models that have the information attached to each piece of equipment or asset or building material. If people use that to build their models, would that not provide the information that people need that you were talking about there? So instead of Kobe system, you populate your model with all of these. You have to have 100%, I guess.
I actually, one of the first big BIM projects I did was a conversion of Starbucks CAD library over to BIM families, kind of smart families, or Revit smart families. I have mixed feelings on it. I think there's kind of a distinction between what type of data you need as an owner versus what type of data you need as a designer. There is a distinction that should be made. And so from a modeling best practice, I think the existing family libraries serve immense value and should be loaded with some data. But it obviously, I'm sure, as you're familiar with, there can't be too much data, and you don't want the geometry to be too good. Otherwise, you're going to end up in a situation where you have Revit models and Revit files that you can't open. The second part is the distinction between, well, first of all, how you get information out of Revit. One of the values of Kobe is that it's an open schema that most CMMS packages can consume, whereas Revit's Kobe toolkit doesn't allow for anything but exporting the parameters that are captured in its toolkit. So, for instance, all the data that you might be related to the air handling unit that is in a family, that information isn't necessarily easy to get out of Revit and then into another system. It is definitely from improving, automating the scheduling process. Because an architect's going to be speccing that type of equipment. So every designer, I think that's actually more of a design decision to make related to what kind of families you want to use and how much data you want to have in your families. Whereas an owner should be specifying that they want information in an open format, which is not necessarily tied to a BIM authoring tool, because the open format is where different people can interact with it. So as Autodesk develops their 360 platform, I would hope that between Vela and horizontal glue, that they'll be able to create a data management tool so that data can be managed external to the authoring model. Because the authoring model should have information in it, but it shouldn't have all the information in it.
Thank you very much.
Reed Monroe with Ellis Dawn. I'm just wondering, in your experiences over the year with all this data that's floating around in a project, have you ever had any issues with proprietary rights or where people were hoarding data or didn't want to share it?
Yeah, all the time. Yeah, unquestionably, that's one of the biggest challenges, which kind of goes back to the owner defining their requirements and being clear about the means and methods, because that allows an owner to declare up front, ideally in the bid process, what they want, what they expect in terms of data and where and how it's going to be managed. Because ultimately that data, I know as an architect or even a general contractor, you have some IP concerns about what you've created. But the reality is what you turn over as a data deliverable, that belongs to the owner. How you get that to them, the outcome, can be up to you. But ultimately data should be shared and it should be exchanged between all the different collaborators. And I mean, ultimately it's the owner. It's the owner's building. So.
Hi, my name is Jos Arpink, representing Stantec. I'm intrigued and frightened by the prospect of ever having to build an as-built model. Can you elaborate on what exactly in this context as-built means?
It means your Revit file reflects, at least within certain parameters, exactly what they're operating. So the way it works for USC and the way it's kind of some other owners are dabbling a little bit in this is that as throughout the construction process you are issued with updates. A lot of times those bulletins will provide the information you need, and you will go to you or your engineering sub-consultants will update what was installed relative to what was from the original design model. Now, the information, the data side, is where it can get a little bit sticky in terms of what's in the model. So what they've been doing is they've been using Ecodomus as the data source of truth for what's going to be provided closeout, because the consultants are responsible for the data. But the representation of what was built is the architect's responsibility. There's a threshold, so you don't have to, everything doesn't have to be exact. But you would be, throughout the process, updating your Revit file on all the disciplines to reflect what they actually installed. There's some limitations, like for instance, they don't ask for every sprinkler head. I mean, they don't ask for every valve, but there are some. An owner needs to determine that with you guys. And actually, that's a good organic process to have with the owner. When you're doing a process, if that's a direction you want to take and do something like that, engage your consultant, make them less frightened, and make sure they understand it's a collaborative process, because they want you to have something of the most value, and your owner doesn't want to have to sue you.
I'm Jean Capriat from 3D Energy. I do energy modeling. So I'm just wondering, can you elaborate a little bit on the integration? Do you integrate from the Energy Plus engine, and do you use that to compare with real-time sensors in order to kind of measure the discrepancies?
Yeah, so that'd be an excellent offline conversation with someone smarter than me. But essentially, a lot of the parameters that you're inputting that you use with Energy Plus are inputted directly into our database where it's measured. And I would love to pair you up with someone who can speak to that more intelligently, coherently than I can. But yeah, and especially, actually that's another good thing. We are very interested in partnering with consultants and technology vendors and other people to improve what we're doing, and we can share some lessons learned. And I'm not afraid of some brain picking if you guys want to call and pick our brains, because we'll pick yours too.